Okay, so good day, I'm Jefferson, Garo, and today we are going to create the summary of our chapter 9. Okay, so let's start. Okay, so I'll be using the slides on the slide share. Okay, so subnetting and IPv4 network. Okay, so reasons for subnetting. Okay, so first, what is subnetting? Subnetting is the process of segmenting a network into multiple smaller network spaces called subnetworks or subnets. Okay, large network must be segmented into smaller subnetworks, creating smaller groups of devices and services to control traffic by containing broadcast traffic within each subnetwork and reduce overall network traffic and improve network performance. So next is communication between subnets. A router is necessary for devices on different networks and subnets to communicate. Each router interface must have an IPv4 host address that belongs to the network or subnet that the router interface is connected. Access devices on a network and subnet use the router interface attached to their LAN as their default gateway. Okay, so our router's IP will be the gateway of our PCs. Okay, next is the planning network or student plan. So there's are the examples. Okay, student LAN, faculty LAN, and admin LAN. Okay, planning requires decisions on each subnet in terms of size, or the number of hosts per subnet, and how host addresses will be assigned. Okay, so it depends on what or who is your client. Okay, so if you are going to uh, create a network on a building, okay, so how many hosts there will be, okay, how to address them. Okay, so it depends on you and the environment that you will be working with. Okay, so basic subnetting. Okay, borrowing bits to create subnets. Borrowing 1 bit, 2:1 equals 2 subnets. Okay, so 2:1. Okay, so there are parts, okay, on our address and subnet mask. Okay, the network portion, our IP address is 192.168 and 1. Okay, and our subnet is 2F5, 2F5, and 2F5. Okay, so host portion is all 0. Okay, 4 zeros, equivalent to 8 zeros. Okay, 0, and 0. Okay, so original. Okay, so 192.168.1.0. Okay, so borrowing 1 bit from the host portion creates 2 subnets with the same subnet mask. Okay, subnet 0. Okay, so you can add 0 on the last. Okay, 192.168.1.0. Okay, so it is minus 127/25, and our subnet is 205.205.128. Okay, so next, okay, so that's subnet 0. Okay, and the subnet 1 is 192.168.1.128. Okay, so because our first is 127. Okay, so subnet news. Okay, there are figures here, how to address them. Okay. So there are steps here on how to create subnets based on their number. Okay, creating 4 subnets, 8 subnets. Okay, subnetting based on host requirements. So 2 considerations when planning subnets: number of subnets required, number of host addresses required, formula to determine number of usable hosts. Okay, 2 raised to n minus 2. Okay, 2 raised to n, where n is the number of remaining host bits is used to calculate the number of hosts, and minus 2 or negative 2, the subnetwork ID and broadcast address cannot be used on each subnet. Calculate the number of subnets. Okay, so 2 raised to n, okay, where is the n is the number of bits borrowed. Okay, subnet needed for each department. Okay, Subnet based on organ structure. Okay, so okay. Subnetting to meet network requirements. Okay. Balance the required number of subnets and hosts for the largest subnet. Design the addressing scheme to accommodate the maximum number of hosts for each subnet. Allow for growth in each subnet. Okay. Traditional subnetting waste. Okay. WASTES addresses. Okay, traditional subnetting uses the same number of addresses is allocated for each subnet. Okay, subnets are required fewer addresses have unused, wasted, unused or wasted addresses. For example, one links only need 2 addresses. So, variable length subnet mask. Okay, or the VLSM. Okay, the variable length subnet mask or VLSM, or subnetting a subnet provides more efficient use of address. VLSM allows a network space to be divided in unequal parts. Okay, subnet mask varies depending on how many units have been borrowed for a particular subnet. Next is network is first subnetted, and then the subnets are resubnetted. Okay, using VLSM subnets, the LAN and WAN segments in example below. Okay, so there's a figure here. Okay, each LAN will be assigned a subnet with over 27 mask, or the subnet mask, and each one link will be assigned to subnet with over 30 mask or subnet mask. Okay, so for you to able to put IP address and mask, okay, you will be in gigabit ethernet 00, or for example an IP address 192.168.20.1, and the subnet mask will be 255.255.224. Okay, so it will be on each LANs. Okay, LANs will be assigned subnet of with over them 7, and exit, then int serial. Okay, send the serial. Okay, so we are working with the routers here. So next, addressing schemes. Okay, planning to address the network. Allocation of network addresses should be planned and documented for the purposes of preventing duplication of addresses, providing the controlling access, monitoring security and performance. Okay, client addresses usually dynamically and assigned using dynamic host configuration protocol or DHCP. Okay. Next is design considerations for IPv6 or IP version 6. Okay. IPv6 bits can be borrowed from the interface ID to create additional IPv6 subnets. Okay. So an IPv6 network space is subnetted to support hierarchical logical design of the network. Okay, so there's here's the summary. Now, subnetting is the process of segmenting a network by dividing it into multiple smaller network spaces. Subnetting as subnet or using VLSM was designed to avoid wasting addresses. IPv6 address space is subnetted to support the hierarchical logical design of the network. Size, location, use, and access requirements are all considerations in the address planning process. IP networks must be tested to verify connectivity and operational performance. Okay, so that's it for our chapter 9 summary. Okay, so thank you.